Hello friends, welcome to my channel Prosto Hub, myself Dr. Jolsna, and today I have come with an important short note, that is stress breakers in FPD. This has been asked in the Maharashtra University of Health Science exam in 2022, and I've got a request from subscribers to do a video on this short note. So let's get into the topic. So, what is a stress breaker? So, GPT-9 defines it as a device or a system that relieves specific dental structures of part or all of the occlusal forces and redirects those forces to other load-bearing structures or regions. So, we have come across the stress breaking concept or the stress directing concept in removable partial dentures, and it is a very important short note. You should never miss out while preparing for your exam. So, in such cases, the dentures with a stress breaker is called as the broken stress partial denture or articulated prosthesis. And what is the significance of stress breakers in an FPD? So, here it becomes important in certain scenarios like a pier abutment case. So, we know that a pier abutment is the one with edentulous spaces present on either side. And in such cases, the pier abutment is subjected to leverage and torsional forces acting on the different parts of the denture. So, in order to protect this pier abutment from this excessive stress, we have to specially design our fixed partial denture using a stress breaker. And that stress breaker is the non-rigid connector. So this non-rigid connector permits limited movement between the components of this fixed partial denture, thereby reducing the excessive stress and torsional forces on the pier abutment. So when a question comes on a stress breaker in FPD, you have to discuss in detail about the non-rigid connector in fixed partial denture. Coming to the contents, the introduction, definitions, the factors that affect the pier abutment case, indications and contraindications of non-rigid connector, the different types, and finally conclusion and references. So before getting into the topic, I request everyone to please do like and share my videos. And if you're new to this channel Prosto Hub, please do subscribe and support me. And actually, I'm getting too many topic suggestions nowadays to make a video. So I think I'll stop taking topic suggestions for time being, and I'll finish all the earlier suggested topics. And once I finish it, I'll let you know, and then you can suggest me more topics. So if you have any queries or you have any feedbacks, you can comment below the video or you can mail me at this mail ID. Introduction. So we know that the success of fixed partial denture depends on the abutment teeth, the pontic design, retainer, connector, and also longevity of edentulous span. So the preferred method of fabrication of an FPD is usually with rigid connector. However, completely rigid restoration is by no means indicated in all situations requiring a fixed prosthesis. So in certain scenarios, rigid restoration is contraindicated, like the case of a pier abutment. So here, in such cases, we have to opt for a non-rigid connector. And this non-rigid connector acts as a stress breaker between the retainer and pontic, and also it diminishes the forces. So the non-rigid connector is enough to prevent the transfer of stress from the segment being loaded to the rest of the FPD. Next, let us see the important definitions. So what is a connector? It is a portion of an FPD that unites the retainer and the pontic. And a rigid connector, it is a cast, soldered or fused union between the retainer and pontic or splintered crowns. And non-rigid connector is any connector that permits limited movement between otherwise independent members of a FPD. So connectors are basically two types. One is the rigid connector and the other one is the non-rigid connector. Next, coming to the factors that influence the treatment plan in a pier abutment case. So there are basically three factors: the physiologic tooth movement, arch position of abutment, and retentive capacity of the retainer. So in this figure you can see the buccolingual movement of the teeth varies according to different teeth, and it ranges from around 56 microns to 108 microns. And there is also apical direction movement, that is intrusion, which is recorded to be 28 microns for maxillary incisors. And we know that mobility of the teeth varies during the day, and it's usually greatest in the morning. The second factor is the arch position of abutment. So because of this curvature of the arch, the buccolingual movement of anterior teeth occurs at an angle to the buccolingual movement of a posterior teeth. So you can see here the faciolingual movement of the canine actually occurs at an angle of 40 degree to the buccolingual movement of a second molar. So these movements of different magnitude and in different directions can create stresses in a long span FPD, and these stresses are transferred to the abutment, and because of this great length through which the movement occurs and also because of the independent movement of the abutment teeth, the pied abutment can act as a fulcrum. So the stresses on the retainer and the abutment teeth can reach destructive level in a rigid 5-unit restoration. So here in this case you can see that the second premolar is the pied abutment, the canine and the second molar are the terminal abutment. So in such a case, if you are using a rigid restoration, the pied abutment can act as a fulcrum and result in undue stresses. And the third factor is the retentive capacity of the retainer. So the excessive force transmitted to the terminal abutment as a result of the middle abutment's fulcrum-like position can cause the weaker retainer to loosen. So here in this case, the canine retainer is the weaker one because it does not possess the length and the inner surface area of a molar teeth. So here the canine retainer is more likely to fail. So these are the three factors that influence the treatment plan, that is the physiologic tooth movement, the arch position of the abutment and the retentive capacity of the retainer. So we have to find out some means that must be used in order to neutralize these destructive effects of the forces, and that is the use of a non-rigid connector. So here the non-rigid connector permits limited movement between the components, and this is enough to prevent the middle abutment from serving as a fulcrum. So this is a broken stress mechanical union of the retainer and pontic instead of the usual rigid soldered connection. Coming to the indications of the non-rigid connector. So when there is different path of placement, that is a single path of insertion cannot be achieved due to non-parallel abutment or misaligned abutment, you can go for a non-rigid connector. Then in case of a mandibular fixed partial denture, which consists of anterior and posterior segment, in this case also a non-rigid connector is indicated as the mandible flexes mediolaterally during opening and closing strokes. Then pied abutment, which we have already discussed. Then inadequate retentive ability of abutment. So in cases where there is inadequate retentive ability of abutment, there also we can go for a non-rigid connector. Coming to the contraindications. So if the pied abutment exhibits significant mobility, you cannot use a non-rigid connector, and also in long span FPD. So if the span between the abutment is longer than one tooth, then non-rigid connector is contraindicated, and in certain situations like a posterior retainer and pontic are opposed by an RPD or an edentulous ridge, while the two anterior retainer are opposed by natural dentition. So in such cases, since there is only a removable partial denture or an edentulous space opposing the posterior abutments, there is chance that the posterior abutment can supraerupt, and this will result in unseating of the non-rigid connector. So a good judgment must be exercised in the use of a non-rigid connector on a fixed prosthesis. Next, coming to the different types of non-rigid connector. So the most commonly used design is the dovetail or the key-keyway, also called as the tenon mortise type connection. Then comes the cross pin and wing type connector, and finally the split type connector. So let us see one by one in detail. So in dovetail or a key-keyway or tenon mortise type connector, the key or the tenon, that is the male component, it is attached to the pontic, and the keyway, that is the female part, is placed within the retainer. The connector can be a precision attachment made from a prefabricated plastic pattern for both male and female part, or it can be a semi-precision attachment whose parts are carved in wax pattern of the pontic and retainer. So it can be incorporated during the wax pattern stage, or it can be made with prefabricated plastic pattern of both male and female parts. And the non-rigid connector, the alignment is very important. It must parallel the path of withdrawal of the other retainer. So paralleling is normally accomplished by means of a dental surveyor. Next, the location of the stress breaking device in a 5-unit pyre-abutment restoration is also important. It must be placed on the middle abutment. Placement of it on either of the terminal abutment would result in the pontics acting as a lever and the middle abutment would serve as a fulcrum. So always the uh, stress breaking device or the non-rigid connector should be placed on the middle abutment. Now, according to Schillingberg, the ideal location of the keyway or the female component is on the distal aspect of the pyre abutment, while the key or the male component is on the mesial aspect of the distal pontic. So here you can see in this picture, the female component or the keyway should be placed on the distal aspect of the pyre abutment. So here it is on the distal aspect of the second premolar, and then the key or the male component should be placed on the mesial aspect of the distal pontic. So here it is on the mesial aspect of the first molar pontic. Now the reason for this placement is that posterior teeth have got a slight mesial inclination and it is shown to move more in a mesial direction on the application of occlusal forces. So when there is occlusal force, the posterior teeth tend to move mesially, and placing the keyway on the distal aspect of the pyre abutment helps in further seating of the key into the keyway every time the occlusal forces are applied. Whereas if you place the keyway mesial to the pyre abutment, it tends to dislodge the key from the keyway, which might lead to fracture of the canine retainer or bone loss around the canine abutment. So here you can see if a non-rigid connector is placed on the distal side of the middle abutment, any mesial movement will seat the key into keyway, and if the non-rigid connector is located on the mesial side of the middle abutment, mesial movement of the teeth tends to unseat the key. So always the accurate alignment of this dovetail is critical. And as we have said, paralleling should be accomplished with the help of a dental surveyor. Now, during the wax pattern preparation, we have to make sure that the anterior and the middle abutment preparation must have parallel insertion path. So, the anterior and the middle abutment should have parallel insertion path similar to our usual 3-unit FPD. The distal abutment preparation need not be in same path of insertion as the other two preparation, but the distal abutment and the box form that accommodates the keyway must share a common path of insertion. So, first the wax pattern for the retainer on the pyre abutment is fabricated on the working cast. So, when we are using a plastic pattern for key and keyway, a deep box form is carved into the distal surface of the wax pattern to create space for the placement of the keyway pattern. So, on to the distal side of this pyre abutment, you have to make a deep box in order to create space for the plastic keyway. An adequate depth and paralleling path of insertion are essential when preparing this box form. Now place the working cast with the wax pattern seated on a surveying table and assemble the key and keyway portions of the connector and then lock the mandrel, that is extending from the surveying instrument to the top of the key portion of the pattern. Now manipulate the survey table until the mandrel and the attachments are parallel with the path of insertion of the distal preparation. So here you can see in this picture, the cast should be manipulated such that A, that is the insertion path of the distal abutment preparation, should parallel the mandrel that is projecting from the keyway assembly on the pyre abutment. So once this paralleling is accomplished with the surveyor, then the keyway pattern is luted to the retainer wax pattern on the surveyor to maintain this relationship. And then this pattern is invested, burnt out and cast. And after the casting has been cleaned and air abraded, carefully we have to cut off any part of the keyway portion of the attachment that protrudes from the occlusal surface. Now place the casting on the working cast and place the prefabricated plastic pattern for the key into the keyway. And at this point, the pontic wax pattern is attached to the plastic key. And then the pontic pattern is completed. It is removed from the working cast. It is invested, burned out and cast. And after the casting is recovered, then the mandrel and any excess portion on the top of the key are carefully reduced so that the key and keyway are in flush. Now, while cementing the restoration also, you have to take care that first place the mesial 3 unit segment and then seat the distal 2 unit portion immediately afterwards. No cement should be placed in the keyway. So, this is about the most popular design, that is the keyway or the dovetail. Next is the cross pin and wing type connector, which is specially indicated in cases of tilted abutment. So as the name suggests, there are two main elements. One is the cross pin and the wing. So here the wing is attached to the distal retainer and it should be fabricated in such a way that it aligns with the long axis of the mesial abutment. So the alignment of the wing should be such that it should be parallel to the long axis of the mesial abutment, and this wing should extend 3 mm mesially from the distal retainer and its thickness is 1 mm faciolingually and it should be 1 millimeter short of the occlusal plane. And this wing along with the distal retainer is termed as the retainer wing component. Similarly, there is the retainer pontic component, that is pontic along with the mesial retainer. So the pontic is attached to the mesial retainer and this is designed to fit to the wing in the retainer wing component. And after fabricating the retainer wing and the retainer pontic components, they are aligned on the working cast and then a 0.7 millimeter pinhole is drilled across the wing and pontic using a twist drill. And a rigid pin of 0.7 millimeter millimeter diameter should be fabricated using the same alloy in order to avoid galvanic corrosion. And this pin should be seated within the pinhole created on the wing and pontic and adjusted to its exact length. So during cementation, first you have to cement the retainer with the wing, that is the retainer wing component, and then be followed by the retainer pontic segment and then seat the pin in the hole with a punch and mallet and remove excess length from the pin both facially and lingually. So this is all about cross pin and wing type connector. Next is the split type non-rigid connector where the attachment is placed entirely within the pontic. And this is particularly used in tilted abutment cases where the use of a conventional dovetail will need the preparation of a very drastic box on the distal aspect of pier abutment. So as the name suggests, here the pontic is split into mesial and distal segment and each of these segments are attached to their respective retainer. So mesial segment consists of the mesial retainer, the pontic, pier retainer along with a distal arm or a distal shoe or key. And the distal segment consists of the distal retainer along with the pontic that has got a keyway to fit over the shoe. And the two components are designed by aligning in a surveyor. So this is the mesial segment with a distal arm and this is the distal segment with the keyway that fit into this shoe. And then while cementation, the mesial segment has to be placed first and then followed immediately by the distal segment, and no cement should be placed between the two segments of the pontic. So this is the split type connector. Let us review an article which was published in Journal of Prosthetic Dentistry in 2008. So this was a study on the stress analysis of the effects of non-rigid connectors on fixed partial dentures with pier abutment, which was done by O'Rourke et al. So here in this study, the aim was to evaluate by means of finite element method the effects of rigid as well as non-rigid design on the stress distribution for 5 unit FPD with pier abutment. So there were 5 models. One was the rigid connector was used and other 4 non-rigid connectors were used, that is at different location, that is connector at the mesial region of the second molar, at the distal region of the pier abutment and mesial to the pier abutment, and also distal to the anterior terminal abutment, that is the canine. So In this study, the analysis revealed that maximum stress concentrations were located at the load areas for all the models, and highest stress values were located at the connectors and cervical regions of abutment teeth, especially at the pyre abutment. So here in this picture you can see for all the models the highest stress values were located at connectors and cervical region of abutment teeth, especially at the pyre abutment. So the pink to blue color represent the stress values, that is pink is of lowest stress value and blue is the highest one. So the study concluded that the stress field changed depending upon the location of the non-rigid connector, and the stress distribution and values of an FPD and a pyre abutment are affected by the presence and location of non-rigid connector. And the area of minimum stress concentration occur in a pyre abutment when a non-rigid connector is located at the distal region of the pyre abutment. So the ideal location of a non-rigid connector is at the distal region of the pyre abutment for a 5-unit FPD. Finally, concluding this session, so to prevent the debonding of prosthesis and eventually the failure of FPDs, the right type of connector should be selected during the fabrication of prosthesis. And in case of a pyre abutment, a non-rigid connector allows movement in the FPD, thereby providing transfer of stresses away from the pyre abutment. And hence, selection of proper connector design is an important step in a pyre abutment case, which will decide the success of the FPD. So these are the textbooks and articles that I have referred for this session. So thank you all for watching the session. Please do like and share my video if you are finding these videos useful. And if you are new to this channel Prostho Hub, please do subscribe to my channel and support me. If you have any queries or feedbacks, you can comment below this video or you can mail me at this mail ID. So it's a bye from Prostho Hub until our next session. Thank you all once again.